So we've covered a numerical example, which was our table, where we just put our data into a table. We've covered a verbal explanation where we just kind of said it in words, described what was happening with the function. We've also looked at a symbolic representation by writing a mathematical formula or a function to describe the relationship. The next one we're going to look at is the graphical representation. And when we say graph, we mean graphical, we mean making a graph. So make a graph of your numerical representation of the relationship between the length of the side of the pool and the number of tiles in the border. Then add the graph of your symbolic representation to the same graph. So we're going to need our data from question number 2. So I'm just going to actually copy it onto here. I'm going to rather largely write it off to the left here. So our x variable, our independent variable, which is running across the bottom x-axis, would be our pool length in feet. While our y value is our vertical, which is our number of border tiles. And then the data that we pulled from the front was that our pool length increased from 1 to 2 to 3. With a corresponding value of 8, 12 when we had a length of 2, and 16 when we had a pool length of 3. So to make a graph just of the numerical representation, that would only include what is on this exact chart. So we would graph these as though they were coordinate points on the coordinate plane, like a 1, 8. So we would ride the elevator to 1, or I'm sorry, walk to 1 and ride the elevator all the way up to floor 8. The next one would be to walk to 2 and then ride up to 12. And finally, walk over to 3 and ride all the way up to 16. And you can see the pattern starting to take shape. However, we wouldn't actually draw in a line yet because this is just representing the numerical representation. But then this second part says, then add the graph of your symbolic representation to the same graph. So the points that we're showing right here, these would be kind of a discrete example. I'm just going to put the dots equal discrete, where they're not continuing, they're just one point, because we're not really having half of a tile or half of a foot. Maybe there's examples where we could, but I think that this kid's family isn't really offering that. However, if we were and we really wanted to think about that, we could also do the graph, which is not going to be, we're going to kind of turn those points into a continuous line, which is going to look something like this. And that one is not discrete. That one's going to be continuous. So I like that they ask this question first, because in question 7, they go on to talk about it. And at least when they ask it, we have something we can look back as an example right here. So this is the graphical representation of the function, where we have pulled the numbers from the table from the numerical and we've put them into the graph to create a graph. And if we just use the points, that would be called a discrete representation. And if we used it with the line, which technically we couldn't go into the negative because he couldn't have a negative size for his pool. And technically you wouldn't even really use 0 because nobody would pay for 4 tiles if they didn't have a pond to begin with. But I think from 1 foot and out, you can tell that this has got some value to it.